Seema, can I just take 5 minutes to address the class?
Yeah. Sure.
Okay. Guys, whoever had problems in the morning regarding your attendance, do you have the out option?
No, ma'am. No, ma'am.
No, ma'am.
Okay. So I have already sent out an email mentioning this. So if you do not have an out option, so that should not be a problem. I think that should be taken care. I will keep you informed about it. Maybe tomorrow's class. I haven't got a response yet. So I will keep you all informed about it tomorrow's class. Okay. For the ones who were able to put your attendance for the morning, just go ahead and submit your out attendance. Okay.
Yes, ma'am.
Okay. Can you quickly answer your attendance, guys? Shubham is here. Salman,
Yes.
Amisha, Ronak,
Yes, ma'am.
who is this? Ronak, is it?
Yes, ma'am, Ronak.
Om Rastogi,
Yes, ma'am.
Bhupendra, Abhay,
Yes, ma'am.
Amar, Nikhil,
Present, ma'am.
Saad Ahmed, Mihir Shah,
Present, ma'am.
Sahil,
Present, ma'am.
Sufyan,
Present, ma'am.
Lucky,
Present, ma'am.
Chetan, Ankul,
Yes, ma'am. Ma'am, Chetan is there.
Chetan is here.
No, ma'am. Internet connection problem. He just left. Yes, he is.
Gaurav,
Yes, ma'am.
Yash,
Yes, ma'am.
Amir,
Present, ma'am.
Roshan, Ravinder.
Yes, ma'am.
All right. Shubham, are you there?
Yes, ma'am. Present.
Amisha, Amar Siddiqui.
Yes, ma'am.
Amisha is here. Okay. Amar Siddiqui. Amar. Saad Ahmed. Right. Guys, for the ones who have submitted your attendance in the morning, please go ahead and submit your out attendance. For the ones who were not able to do it, I will take care of that.
Hello. Ma'am, have you marked my attendance for the morning session?
Yes. Chetan, right?
Ma'am, I'm present.
Yes, I have done it.
Ma'am, and mine, Ronak.
Yes, Ron, I have done it.
Yeah.
Ma'am, mine.
Yeah. Yes, done, guys. Done.
Okay, folks. So let us continue with our networking. So we have covered lots of stuff today. So when we are going to go to the canvas, now I'm pretty sure that you are able to answer lots of KC. Okay. So we had elaborated the IP addresses, the basics of IP addresses. Definitely, I have not started the advanced IP addressing yet. Okay, that is the subnetting. So that part is not yet done. So this part is remaining. Okay, but before that, what I will do, I will just take you to the router, introduction to routers first. Those presentations I'm going to cover right now. Now, as I have already shown you in my simulator, right? Router is inter-networking device. It enables communication between two or more different logical networks. So it depends how many interfaces the router has. Okay, so the routers are identified with this symbol. Okay, so this symbol, or sometimes it gets identified with this symbol as well. Okay, so now this router is having multiple interfaces onto it. So depending upon the interfaces it is having, it is getting connected to different networks, right? So that's why network A will be able to communicate with network B, C, and D if they are connected to the router. So in this example, all these networks are connected to the same router, but it is not required, right? So simply it is possible that this router is there, this router is there, right? And now this router is connected to network A and network B. This router is connected to network C as well as network D. So if you connect these two routers, then A, B, C, and D networks can communicate with each other, right? So this is also possible. We are going to elaborate this scenario in my simulator as well later on, not right now, because here you need to configure the routing, the route table in the router. So that we will take it in the upcoming sessions later on. Okay, so it enables communication between two or more logical network, and it is network layer 3 device. It is network layer, that is layer 3 device of the OSI reference model. So yesterday we have seen that one, right? It comes from the word root, hence it is also a device that finds the best path for your network. IP address of router is the default gateway for all devices in LAN. So no need to explain this now, right? Because we already done that in the demonstration. So how if the default gateway is not there, the computers will not be able to communicate with other computers which belongs to different networks. So that address is again a crucial one. Okay, there are two types of router. We are not going in detail of this because this is not the networking class basically. Okay, so this is not the advanced networking class, I will say. So the routers can be the hardware router, and the vendors of this router include Cisco, Juniper, Multicom, HP, D-Link. So most probably you are having this router at your home, D-Link, MyPo, and many more. And even software routers are there. You can configure Microsoft Windows Server operating system as well as Linux operating system to act as a router. Okay, so if you are having the Windows 2016 or 19 or whatever operating system, you can configure the service RRAS service, routing and remote access services. Once that service is installed on this computer, this server will act as a router. So definitely it will be a software router, not hardware router. Hardware router is a special device. Okay, so you need to purchase, and trust me, these are very costlier devices. So lots of organizations prefer using definitely small organization. Okay, so for large organization it will not work, but just take example that you are having multiple departments in your computer and you just want to connect those departments, so it will be a good solution for you. So instead of investing lots of money on that hardware router, you can use this server operating system to act as a router. Fine. So I think we have taken a little bit similar scenario, not as defined in this picture, but somewhat closer to this. So functions of the router, it is an inter-network communication. It selects best path. So for example, one computer from this network wants to communicate with one computer which belongs to this network, right? Now what this router will decide? This router will check what are the paths available for it to reach to the destination network, right? So it will definitely not think about the destination computer. Routers will always think about the destination network. Okay, so routers will just leave you till here. Then the switch will take the other essential things, right? So now from this router's point of view, what are the paths available? This path, right? This one is one path to reach this network, and this is another path. Now it will count the routers in between. So now if it takes this path, the count is one hop because it has to cross one router, right? And if it calculates this one, the hop is 0. It means that there is no router in between. So if the traffic is not there, then this path will be preferred. Okay, because it is it is the shortest path. It is the shortest path because it is not having any router in between. Okay, but if it is the congested one, and then definitely it will prefer this path. So best path selection is the function of router. Packet switching Now, just I have told you. So, for example, what do you mean by packet switching? The router is there, and to this router, multiple networks are connected. Okay. So, if the computer from network A or wants to communicate with computer in network B, the packet will first go to the router. Now, this router will decide where it is going to switch that packet to this interface or this interface. Now, depending upon the destination IP address of that computer or that network maybe, so it will decide. So, it is known as packet switching. So, the packet will get switched from this interface to this interface or from this interface to this interface. So, this is packet switching. And then comes packet forwarding. Now, if it is the only router in between those two networks. So now see, now let us have this scenario. This is one router. This is another router. This is another router. This is another router. Okay. And let us say this is one more router. And to this router, the destination computer belongs. Our computer belongs to this network. And the source computer belongs here. Now see, there are lots of paths available. Okay. Lots of paths available for the destination. Now, initially the packet reached to this interface. Now it is going to switch to different interface depending upon what is the shortest path, right? And then it is going to forward it. So from this interface, let us say it is forwarding this, then this router is going to forward till it reaches the destination. So packet forwarding, packet switching, path selection, these are the features of the router. Different types of router, fixed routers are there and modular routers are there. In fixed routers, it is not possible to add or remove the Ethernet ports. Okay, but in modular routers, it is possible. Let me just show you. In my packet tracer, I can show you what the modular routers are. Now, if I just take you to this router, okay, so if I just go here. Okay, so now see, these ports are empty. I need to switch off the router first. Right now it is on. The green LED indicates that it is on. Let me switch off it. So once it is switched off, I will just take any interface. For example, okay, I want to add this port. Okay, so see, this is what I mean by modular. This slot was empty, but now I have added that interface. Now to this interface, maybe I want to add this one. Okay. So this is what I mean by modular. Once I am done, I can remove that as well later on. Okay. So now once these are done, I can switch on the router and now it will have those interfaces. So this nature of router is known as modular router. So once it is required, you add that interface. Once you are done, you can even remove that interface. Now my router, because it is switched off and it will not work right now. Fine. So modular routers are upgradable and you can add or remove the interfaces as per the requirement. Number of slots available depends on the series of router. Okay, so how many slots are available? That totally depends which series of router you can using. You can add LAN as well as WAN cards there. So these are the fixed router and modular router. So this is the fixed one and these are the modular routers. Okay, so these are the series of routers. So we are not going in that much detail. Okay, but yes, if you should know, these are the series: 800 series, 1900, 2600, 2800, 2900 series. And in that series, we are having the different models of the router. Okay, fine. We are not going in that detail. One more presentation for router. It is a device which connects multiple networks together and router routes traffic from one network to another network. And these two networks could be a private network or public network like internet. This is how the router works. And if you see, we have elaborated the same scenario. Instead of hub, we have just taken the switches. Otherwise, we have elaborated the same scenario in our packet tracer. Okay. So now, this is the local network. Consider it as your home network, right? So this is the home network. This is your LAN. And then router will sit in between your network and the internet. And it enables this communication. Okay, so let us little bit talk about the home router. So maybe Linksys or D-Link, these are the models we are using at home. There are two kinds of routers available to provide internet connection at home, wired as well as wireless. When you sign up for a new broadband connection, you will receive that wireless model rather than the wired one. Okay, because wired ones have become outdated nowadays. So nowadays we are having the I will say the mixed one, which will support both the wired connection as well as the wireless connection. Now, our home router is a special device, I will say. It is a combo device. It is having lots of devices inside it. It is acting as a switch, right? It is acting as a switch. Definitely, it is acting as a modem because it is getting you connected to the internet, right? And even just now we have seen it is acting as a DHCP server as well. It is assigning IP addresses to our automatically to our home devices. So lots of things are done at the home router. This type of hybrid device, sometimes called a gateway, is offered by some ISPs to the customer to simplify the internet setup at home, right? So mostly the service providers give these routers to us. Okay, it is actually a combination of two devices, modem as well as router. I will add some other things in it. It is actually acting as a switch also. Modem is a hardware component that allows a computer or other devices such as router or switch to connect to the internet. So nowadays we are not using modem as a different device, but initially we were using that. Router creates wireless LAN of all home devices which are capable of connecting to the internet, such as your PC, your laptop, your smartphone, your smart TV, and connect this network to modem, which provides the internet connection. When you plug your phone line or cable, whatever internet connection you are having at your home, so if it is the phone line, you will plug it in the RJ11 port, right? But if it is you are having that internet connection through cable, right? So they are providing you the different router as well as different ports there. So the Wi-Fi router then takes this data and converts it into radio signals, which are then picked up by the devices with Wi-Fi capability, such as your laptops, tablets, smartphones, and so forth. Yeah, this is the example. Okay. Now, although it is not relevant to this section maybe, but yes, there are certain security measures that you should follow. We are going to talk about this in our next module, security module. But yes, there are certain things you should consider when you are using the home Wi-Fi router. Change your default password for the router. Okay, change default SSID name. Disable SSID broadcast. Use encryption methods. Default, the router will definitely have that encryption, okay? But don't select WEP. It is easily crackable. So think of using a WPA or WPA2, or nowadays we are even having the AES encryption standard there. So those are the advanced one. But WEP is very, I will say, easily cracked. You enable a MAC address filtering, enable router as a firewall. Yes, if you connect to your home router, you will see these options are there. You can configure your router as a firewall. You can enable MAC address filtering at your router. Your router is having the operating system that is known as firmware, iOS, right? And when not in use, it is a good idea to switch off your router. So these are certain things. We will talk about this in detail when we are going to go to our security module. But yes, these are the ones. So now the question is, how many of you are following anything from this? You know about this, all these things? Okay, let me change my question. What do you mean by disable SSID broadcast? What will happen if I disable SSID broadcast? What will happen? Anybody? What is SSID?
Full form of SSID, ma'am.
See, these are your SSIDs. So if I take you here, so see, I have connected to my network, that is J-Hope. This is my SSID. Okay. So this is security identifier definitely. So now this is one SSID. This is another SSID. I don't know. These are my neighbors, right? So Vikrant and somebody. Okay. So now, if this is not my network, if I double click onto it, okay, so if I just try to connect onto it, it is going to ask me the password. Okay, so now if this is not available to me, so first of all, I don't want this network should be available to anybody. They should not able to see that J Hope is there, or maybe this Geo is there. Okay, so unless and until they see, they will not double click on it to check my connectivity or guess my password, right? So this is something which is known as broadcasting your SSID. So it is always a good idea not to broadcast it, so that your network will not be visible to anybody which is close to your premises. This is what I mean by disabling SSID. But disabling SSID doesn't mean that it is not going to get disclosed. If the person is having some scanning tools, okay, network scanning tools, so those scanning tools will be able to identify this network. Although normally it is not visible if you disable the SSID, but yes, if you are having some scanning tools, then yes, those can be revealed. Okay, so now change default SSID name. So I think most of the networks which I can see here, they have changed the name except this Geo. So this is the default SSID name. Okay, so this is the default SSID name, but other people you can see they have given some name to their network, hidden network or something. So this is something which is changing your SSID. Otherwise, if you are using the BSNL connection, you will have some SSID as BSNL, maybe MTNL, maybe, right? So if you are using some Airtel, so maybe some other unique name. So from that name, you will be able to identify which network these people are using. So don't reveal your network, right? So that is what I mean by change default SSID name. Change the default password of your router. So if you go to Google, okay, so now see what happens. If I just go to this default router password, okay, so see. I can see these are the types of the routers, okay, D-Link, TP-Link, Netgear, Linksys, and so forth. So we are not using everything in India, but yes, we are using D-Link, Netgear, Asus, Linksys as well. So now, if I am close to your premises, okay, if I'm close to your premises, and especially if I'm having the relevant hacking tool, I will just try my luck that I will use 192.168.0.1 or maybe 1.1, depends which router you are using, right? And then I will use the username as admin and password, whatever has been mentioned. So lots of people, what they do not change this username and password. Okay, so if I'm close to your premises, I can actually access your router. So if I access your router, I can change all the settings of your router. So what settings can be done at the router level? You can use enable MAC address filtering. I think I have talked about this before. I am not sure whether I have talked about this, but what exactly it means by MAC address filtering, MAC filtering. So this is your home router, right? And what is happening? So your home devices are getting connected to this router, and then that router is taking you to the internet. Okay. Now, let us say somebody was able to access my router. He was successful in using the username and password, maybe something, whatever. And maybe he was able to get my password, something, I don't know. But yes, this is some outside person and he is trying to use my internet connection. So if he knows the username and password, definitely he will be able to access that internet. Now see, nowadays, people are not using your home network just because they want to save their money, they want to save their bandwidth, they want to use your bandwidth. That is definitely not the reason why somebody else is using your network. Definitely if he is not known to you, right? So if he is your friend or some colleague maybe, or some guest at your home, that is perfectly fine. But other people, you know, they are using your internet connection for some different reason. And what is that different reason? That different reason is to perform some illegal things from your router. Okay, so maybe to do some scanning type of things, to perform some hacking attempts on their target, they will not use their network because they will get revealed, right? So here what will happen, if they are using your router, it is you who is going to get caught there. Okay, not that person. Okay, not that person. He will not have any problem because ultimately it is identified as your network. So this is very crucial nowadays. So don't allow anybody to access your home network. So for that, one trick is that we can use MAC address filtering. Very good trick in the router or technique in the router. So here what we do, we know what are the MAC addresses of each and every device in your home, right? We know the MAC addresses. If not, we can even find it out using the IP config command, or even in your cell phones as well. You can find out the device address, right? So MAC address is also available on your Android or maybe your iPhone also, right? So you can find out. And now you configure your router that such and such 5 MAC addresses are there at my home, 5, 6, 7, whatever you are having. So if the internet connection is getting requested from these addresses, then only give the access. Otherwise, if somebody is trying to get the internet connection and that MAC address is not from this list, then that connection should not be allowed. So this is very good for security. Okay, so this is what I mean by enable MAC address filtering. Every router is having that option. Every router is having that option. But the thing is that we are not aware of that. Okay, we don't know that such settings are there. Even we can configure the firewall. Our router is having the operating system firmware, right? And the vendor of that router is actually providing the updates to fix the patches, maybe to fix any vulnerabilities, if at all they are having, because ultimately it is the operating system, right? So if at all it is the software, so if at all some vulnerabilities are there, they are going to provide some fixes or patches for that. So how many of you, it is really a question, that how many of us are actually upgrading or updating our router's operating system? Literally, I think at least 1 or 2 participants will say that, yes, that we are doing that. Okay, but otherwise everybody will say that we don't know such things are there. And yeah, that is where we are lacking in knowledge of that security, right? So right. And the last option, yeah, very good option, very good for security. Turn off the router when not in use, because lots of things happen when at night when nobody is using that router, I will say. Okay, so that has to be taken care of. If it is not in use, just switch it off. Even it is going to save your electricity bill and your carbon emission as well. Okay, so you are saving the environment in that. So that is always a good idea. While sleeping, when nobody is using that router, you should just change it, right? Or switch it off. Change the default password. SSID, it is the identifier, service set identifier. Actually, it is a 32-bit alphanumeric identification given to the devices. Device which wants to connect to the wireless network with an SSID enable must have the same SSID to communicate. Just I have told you, you need to know that SSID. When connecting to a home network, you may see multiple SSIDs from your neighbor's wireless router. Change the default SSID name. SSID is the name that identifies your wireless router. By default, many routers will use the name of the router as the default SSID. For example, Linksys or Linksys something, or maybe something like that. Okay. So using a default SSID is a security risk because it identifies the brand of the router. It would help an attacker find a way to exploit the vulnerability in that device. So that's all. That's why we should not keep that name. Disable SSID broadcast. To help make finding your wireless network easier, wireless routers broadcast their SSID, which means anyone looking for a wireless router could see your SSID. So just disable it, as I have already talked about it. Okay, so many routers today offer 2 or 3 different security schemes: WEP, that is wired equivalent privacy, or Wi-Fi protected access. So WPA is the more advanced one, and in that also WPA2 is the more advanced one. Okay, it is recommended to use WPA or WPA2 since it is more secure than WEP. Enable wireless MAC filtering. So just I have talked about this, right? and enable your firewall. Many routers also have a firewall. Mostly all routers are having the firewalls in it. So if required, you can even configure that and keep your firmware up to date. And the last option is turn off your router when it is not required. So these are certain things which were related to security. Anyway, so I have covered that as well. So those are the things which were related to the router. Now let me take you to IP address part 2. Okay, so far we have seen IP address is a logical address. It is assigned, the IP is a layer 3 protocol basically. Okay. And there are two versions of IP addresses, 32-bit as well as 128-bit. And now it is easy for you to identify this. So it is the 32-bit address, which is divided in 4 octets and separated by dots, which are known as periods. So in this example, we can see it is 85.5.191.1. It is the IP address. Fine. Now, how to convert that IP addresses? We are going to see that these now. Okay, so the conversion, we are going to talk about the convergence. Okay, now see, this is the binary address. Okay, so it is all the game of zeros and ones. Total 8 bits in one octet, and that values will be zeros and one. So if what are the combination possible? If you just want to change these, you want to use all the permutations and combinations of ones and zeros here. So how many combinations are there? It is 2 raised to the power 8, which is 256 combinations are possible in every octet. Okay, in every octet, 256 combinations are possible. So the first will be 0000 as we know, and the last will be 111111. So the total range of IP address range, if you consider this octet, right? So it will be from 1 till 255. So if you see any number which is above that, okay, so maybe 258, 259, 260, so it is indicating that it is the invalid IP address. Now these are the binary to decimal conversion. Now just take example. Just hold on. Okay. So this is 2 raised to the power 0 position, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4, 2 raised to the power 5, 2 raised to the power 6, as well as 2 raised to the power 7. See, these are our 8 bits. And every bit is having the position, right? So just like your decimal number, if I'm taking 536 number, let us say. So how this number is exactly, it is 500 plus 30 plus 6. So this is units place or ones place, right? This is tens place and this is hundreds place. So how I have calculated this? 5 into 100, that is giving me 500 because this is the hundreds place. Then 3 into 10 because it is the tens place, right? And then 6 into 1, that is the ones place. So this is what we have done, right? Maybe in our school days we did this one, right? Expansion something. So this is the place and the positions of those numbers. So similarly, in our binary number systems also, those bits are having the position. So this is the zeroth place or first bit, maybe this is the 1s, 2, 3, 4, 5, 6, as well as 7. So total 8 bits are there. So first is the 0th position, 1, 2, 3, 4, 5, 6, and 7. Okay, fine. Now, if you take any number, now let us say I'm giving you one number, 11000000. So this is the number given by me to you to convert it in decimal. Okay, so this is the binary number 11000000, and I have asked you to convert it in binary. So first of all, you should know this position. 2 raised to the power 0 is 1, 2 raised to the power 1 is 2, 2 raised to the power 2 is 4, 2 raised to the power 3 is 8, 2 raised to the power 4 is 16, 5 is 32, 6 is 64, and 2 raised to the power 7 is 128. So I will just write those bits below those numbers. Okay, so now see, this is 128 multiplied by 1. So it is 128. 64 multiplied by 1. It is 64. So 128 plus 64. Rest all are zeros. So this is 32 multiplied by 0, which is 0. 16 multiplied by 0, 0. 8 multiplied. So all these numbers will come out to be 0. So if I just calculate 128 plus 64, it is going to be 190. Okay, folks. So will it be possible for you to do this conversion? Shall I give you some numbers?
Yes, ma'am.
Okay. Okay, so randomly I'm going to give you some numbers. Okay, let us try. Okay, this is the number. I want you to convert it in decimal. So you will use this conversion, right? 2 raised to the power 0, 1, 2, 3, 4, 5, 6, as well as 7. So you are going to write these numbers below it. And as we have already seen, this conversion, this is 1, 2, 4, 8, 16, 32, 64, as well as 128. So this number, it is 0. So the answer will be 0 here. So you just need to consider those numbers which are 1, 1, 1. Otherwise, it will be 0, right? So what is the answer now? 128 plus 64 plus 16 plus 8 plus 4. That's one, right? So what is the answer?
220.
220.
228.
So 228. Okay. So 228. So this is how we convert. Everybody, are you okay with this or not? Anybody having any doubt or something?
No, ma'am.
No, ma'am.
No, ma'am.
Good. Okay. Take one more example then. Okay. I want you to convert this. These are special numbers which are starting from the left side 111. So they are having some sense. Okay. So when we are going to go for subnetting, they will make some sense. Okay. That's why I have given this number.
$240.
This is 240. Okay. What is this?
$255.
255. So making all the bits as 1 is the 255 number. That is the maximum possible number in any octet, right? Okay, it's fine. So this was conversion, and you must be knowing we are having the calculators as well. Okay, so no need to all do these calculations, definitely. So we are having the calculators nowadays, okay? But still, it is always a good idea. You should know how that conversion is done. Okay, so now, for example, I want to convert that same number 1, 1, 1, 1. Sorry, just hold on. Okay, and what is the equivalent of this in decimal? It is coming out to be 240. Okay, so it is 240. So it is very easy to convert, but yes, you should always know how that conversion is happening. Now let us try to do it in reverse way. Now I'm giving you one number, okay, 100 and let us say 30. This is the decimal number, and I want you to convert it in binary, not using the calculators of your computer. Later on we are going to use it, okay, but initially we want to be much more clear how this conversion has to be done. So again, I will use the same table see, there are multiple methods. Probably you are using some other methods. It is perfectly fine for me, no problem. You can use any method if whatever you wish. What is this number? 130, which we want to convert, right? So what you are going to do, you just look at this number and select that number which is less than this 132 and closer than this, closer to this 130 comparatively. Now, as we know, all these numbers are less than 130, right? All these numbers are less than 130, but you should select that one which is closer to this 130. So it is 128, right? So what I will do, I will mark 1 here. Okay, so if you deduct 128 from this, now the remainder is 2. Okay, remainder is 2. Now again, look for the number which is less than or equal to this number, closer to this number. But now here straight away we are having the number 2 as it is. So I will mark 1 here. Okay, and lest all the numbers will come out to be 0, 0. So now this number, see, 128 plus 2 is going to give me 130. Okay, this is one method. Some people prefer calculating the LCM and then converting that. That is perfectly fine. You can use any method and you can convert it. Okay, so let me give you one more number then. I will just keep it as it is. I will not remove this table. Okay, it will be easy. $240. I want you to convert this 240. Okay. Lucky has given me answer 1111. That is perfectly right. Okay, but how we have calculated that? Okay, so those who are knowing it, well and good. Otherwise, I will just explain you. Now, see, look at this number 240. Select the number which is less than or equal to this number in this chart. Okay, and which is closer to this. So again, in this example, it is 128, right? So that is the number which is more closer to this number and less than this. So now 240 minus 128. It is 1112. Am I right?
Yes, ma'am.
Yes, ma'am.
Okay. Now look at this 112. Now again, look at the number which is less than or equal to this 102, closer to 102. So we don't have any option. It is 64, right? It is the 64 number. So now 112 minus 64. It is 48 this time. So again, look at the chart. So go to the number which is closer to the 48. Again, it is 32. So subtract 32 from here. 16. Okay. So now we are having the exact match, 16. So just have now the remainder is 0, right? So go on doing this till you get the remainder as 0. And once it is done, make all the numbers as 0. Okay. So one more from my side now. And now you are going to give me the answer. Okay. Do it for 100. Do it for 10 as well. Okay. Two numbers, 10 as well as 100. 10 will be very simple. For 100, it is 0, 1, 1, 0, 0, 0, 1, 1. Okay. Fine. Great. So everybody is perfect in that. Okay. So see, this information or this knowledge is required definitely when we are going to go for subnetting. So lots of calculations are to be done when we are going to go for subnetting. So this is the basic for that. Very good. Okay. So this is binary to decimal and this is decimal to binary conversion. I hope everybody is good in that. If at all you are not getting, please let me know. I will again elaborate it. Okay. So we have seen this classification of IP addresses earlier, right? And we have seen that we are using these ABC addresses in LAN as well as WAN. This D is for multicasting as well as E is, we are not using it. It is just the research and development. Now, let us talk about this priority bit. Okay, folks, let me just go through this first. Okay, now, if I have given you the IP address in decimal form. Okay, so 4 IP addresses, let us say I'm giving, and quickly you are going to tell me in which class that IP address belongs to. Okay, so first address is 100.10.5.3. Second address, I will say 7.5.100.2 maybe. Third IP address, I am using 150.50.50.50 maybe. And then I'm using 200.10.5.3. So now tell me what are the classes. The first IP address?
A.
A. Looking at the first octet, if it belongs to 0 till 126, it is your class A, right? So yes, this is class A. So again, this 7 number again belongs to the same range. So it is class A. What about this?
B.
B. 128 till
191.
91 will belong to class B. So it is class B. And this is class
C.
192 till 223. So this will belong to class C. Now see, now you are very expert in this. If I'm giving you IP address in decimal form, you are telling me what are the classes, right? But now, if I just give you these IP addresses, okay, so as we know, we are just identifying the IP addresses from the first octet, okay? So there can be any number in the last 3 octets. We don't care about it. So what I will do now, I'm giving you some numbers. Okay, so this is the first octet. I don't know what other octets are. It can be any one. So this is another number. This is another. Sorry. Something. Now it becomes difficult, right? So if I'm asking you, now tell me, so these numbers can be any numbers. We don't know. Okay, it can be any numbers because to identify in which class that IP address belongs, we are just looking at the first octet, right? Now, what you will do usually that you will first convert it in decimal, right? You will convert it in decimal and then you will tell me that whether it belongs to class A, class B or class C, right? This is what we are doing. But now there is a concept which is known as priority bit. So let us see how simple it is to tell in which class that IP address belongs to if you go through this priority bit. So see, so just look at the first bit in that octet, okay? Just look at the first bit in that octet. If it is 0, okay? If it is 0, so now see, there are 8 bits here, folks, 8 bits, okay? So in every octet, there are 8 bits. But see, we are just looking at the first bit now. So if the first bit is 0, don't look at any other bit. It is class A. If the first bit is not 0, then it will be 1 because there are just 2 combinations, right? 2 possibilities are there. So if it is not 0, then it has to be 1. But now, if it is 1, then look at the second bit also. Okay. Now, if it is 1, then look at the second bit. Now, again, there are 2 possibilities. The second bit will be either 0 or 1. Now, if the second bit is 0, then it belongs to class B. If the second bit is not 0, then it has to be 1, right? So first bit is 1. Second bit is either 0 or 1. If it is 0, you are done. It is class B. But if it is not 0, then look at the third bit as well. Now again, there are two possibilities. Either it can be 0 or it can be 1. If it is 0, you are done. It is class C. If it is not 0, again it has to be 1. So if it is 1, look at the fourth bit. Okay, so again there are two possibilities. It will be either 0 or 1. If it is 0, it is class D, and if it is 1, it is class E. So merely looking at the first 4 bits now, you will be able to tell me in which class that IP address belongs to if it is been given in the binary form. Okay, so routers actually identify the IP address using this leading bit concept. We call it as leading bit, or maybe we call it as a priority bit. So is it clear? So how to identify the IP address? And if you consider this, you should automatically get the answer to the one. Nobody asked me about that. Okay, but if you just go to the previous slide of IP addressing, this slide. So nobody asked me why this odd division, why it is 126, why it is not round figure, why they have not taken it till 100, why it is 191, why it is not 190 or 195 or some round figure. Okay, why it is 223. Now you got the answer. Why the answers are, why the distribution is something like this. It is because it is binary. Now, for example, you can take any number. You can take any number from 1 till 126. You take any number from 1 till 126 and convert it in binary. Okay. The first bit will always be 0. Now take any number from 128 till 191 and convert it in binary. The first bit will always be 1 and second bit will always be 0. Take any number from 192 till 223. These first 3 bits will be always this. Take any number from this. First 4 bits will be this. And here first 4 bits will be this. Okay. So these bits are fixed, and because of that, so as soon as you go from 127 to 28 till 127, the leading bit will be 0. But as soon as you go to 128, the leading bit will change to 1. So till 191, the leading bits will be 1 and 0. But as soon as you go to 192, the leading bits will be 1, 1. Okay, so that is why these separations are done. So these are known as leading bits. Is it clear? Okay, so going back to our presentation. Yeah, this is what I was talking about. So these are known as the priority bits. So looking at the priority bit, you can tell in which class that IP address belongs to. Okay, so this we have already. Okay, now let us take example of class A. Okay, this is the example of class A. So just now we have seen in class A, the first bit will always be 0. Okay, first bit will always be 0. So now whatever combinations are there, that will happen from this 2 raised to the power 0 till 2 raised to the power 6 only. Okay, so you will not be able to change anything here. So this bit will always be 0. So what is the minimum number in this octet in class A? All zeros. Okay, now once you go for any combination, the last will be this one. So you got it now? Why the first class A is having the range from 1 till 127. Actually, it is 127, but because 127 is the loop back address, okay? Because it is the loop back address, we have not mentioned it in this slide. Okay, so see, first number 0 and all the rest are 1, the number is going to be 127. This is for class A. Now, let us talk about class B. In class B, just now we have seen first 2 bits are fixed. That will always be 1 and 0. So those will be 1 and 0. So rest bits can be all zeros till all ones. So you are having all the combinations in it. So if you convert it, the first number will be 128 and the last will be 191. So in decimal form, the IP address range for class B will be 128 0.0.0 till 191 255 255 25. Okay. Class C, first 3 bits are fixed now. So you are just having 5 bits to play with. So the minimum number is 5, all the zeros, and maximum is all the ones. So if you convert it, it will be from 192 till 223. So the class range is 192 0.0.0 till 223 255 255 255. Then class D, although we are not using this class D, but see, this is what is happening now. First 4 bits are fixed. You are just having 4 bits to play with. So if it is all 0, it is 224. If those 4 bits are all ones, it will be 239. So this is the maximum, this is the minimum, and in between you are having these numbers. So the range is 224 000 till 239 255 255 255. You know 255 is the maximum number, right? So in the remaining octets, in the remaining 3 octets, so all these 8 bits will be either 0, 1 or in between. And class E, first 4 bits are fixed now. They are 1 1 1 1 1. And now if all the remaining 4 bits are 0, it is going to be 240. I think we have converted it initially. And the last is 255. See, so this is the maximum number in any IP address. So if all the 8 bits are made 1, then the number will be 255. So the class E range is 240 000 till 255 255 255 255. So this is how your addresses are separated. Class A, class B, class C, class D, as well as class E. Okay, now just hold on. So already answers are given here, but at least we can try. Now see, this is one IP address. Now you are going to identify the class, and I think it will be very easy for you. You are just going to look at the first number. So this is class A. This IP address 192.111. So look at the first number. It is class C. 224 0.0.10. It belongs to class D. 120 200.11 class A. Just look at the first number. Just look at the first number. It is class B. But this is the invalid IP address. Why? Because in any IP address, you cannot have a number which is greater than 255, right? And that is the reason this is the invalid IP address, because of this number. Okay. So this IP address is divided into network and host portion. Now it is very easy for you that instead of writing this 255, just hold on, 255, I can write in 255.0.0.0 can be written in this way. Network, host, host, host. So it is equivalent to 255.255.0.0. So this is network, network, host, host. So NNHH. So again, 255.255.255.0. This is for class C. So network, 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 and host portion. So either you write subnet mask in this way or this way. Okay. So certain calculations are there now. Okay. So we will just go for this one and then we will wind up for the day. So now, okay, instead of going for class A directly, I will go for class C. It is easy. Okay, so first we will go for class C. Now have a look at this. So in class C, we are having first 3 octets for network and last octet is for host. Okay, so bitwise, I will say 24 bits are there for network addressing and 8 bits are there for host addressing. Okay, 8 bits are there for host addressing and 24 bits are there for network addressing. This is for class C because the subnet mask is 255.255.255.0. Fine. So now the question is, how many networks are there in class C? How many possible networks are there in class C? So it is 2 raised to the power 24 for sure, because 24 bits are there for the network. And how many hosts are possible in each network? It is 2 raised to the power 8. If you calculate this 2 raised to the power 24, but just now we have seen in class C, first 3 bits are fixed. And what are those? 1, 1, 0. If I just take you back to that slide. Class C, 1, 1, 0. So although we say that for class C, it is 255, 255, means 255, 255, 2550. This is the subnet mask of class C. But out of that first octet, first 3 bits are fixed. We are not able to change those 3 bits, right? So actually, out of those 24 bits, we are left with just 21 bits for network addressing, right? We can't do anything with that first bit because it is class C, those will always be the fixed one. So how many bits are left with us now? The 21 bits. Are you getting this calculation? Out of 24 bits, first 3 bits are fixed, and that's why I'm just left with 21 bits for network addressing, right? And now if you calculate this 2 raised to the power 21, the number will be 2097152. So this much number of class C networks are available now. Okay. And how about the, now see, this is a big number. 2097152 networks of class C are available. So if you take any class of class C, how many computers you can have in that network? So how many hosts can be accommodated in that network? So as we know, now 8 bits are there for the host addressing, right? So 2 raised to the power 8 number of hosts will be there, 256. But out of those 256, in the host addressing portion, the 2 combinations will be, one combination will be all zeros and the last combination will be all ones, right? So I'm talking about the last 8 bits. So we cannot use these 2 combinations, all the zeros and all the ones, because all the zeros is used to identify the network address and all ones is used to identify broadcast address. So that's why we cannot use these 2 combinations. So out of that 256 now, I will subtract 2, number 2. And now that is going to give me 250. Okay. So how many computers can be connected in class A network, sorry, class C network? It is 254. Are you getting this calculation or not? Anybody having any doubt here? Is it clear? No doubt?
No, ma'am.
Okay. Now let me take you to class B then. Now in class B, the subnet mask is 255.255.00. So this is the subnet mask of class B. 255.255.00. That is network, host. So it means that 16 bits are identifying the network and 16 bits are used to identify the host. But if you go for the leading bits now, first two bits are fixed. That is 10 for class B. And that's why out of these 16 bits, we cannot use 2 bits for network addressing. So we are just left with 14 bits. So that's why number of networks in class B will be 2 raised to the power 14. And if you calculate this, it is 16384. And regarding the host addressing, now we are having 16 bits for host addressing. So definitely it will be 2 raised to the power 16. But out of those 16, okay, so 2 combinations are again there. So these 16 bits, right? These 16 bits. So one combination will be all the 16 are 0 and the last is all the 16s are 1. So we cannot use this because this is for the network address and this is for the broadcast address. So deducting those 2 combinations, we will be having 65,534 computers per network in class B. 65,534 computers. So if you create this network of class B, okay, So how many computers can be connected in that network so that they will communicate with each other? It is 65,534. In class C, it was just 254. That is a small network, right? So if you are creating a class C network, how many computers can be attached to that network? Okay, so this switch, maybe I want to create a network. So the maximum is 254 only. Okay, now let us go for class A. Now in class A, the subnet mask is 255,000. It means 8 bits are there for network addressing and 24 bits are there for host addressing, right? So in this 2 raised to the power 8 combination, now for class A, the leading bit is 0. Just 1 bit is fixed, right? 1 bit is fixed. And if you deduct that, so it will come out to be 2 raised to the power 7. So we are having 126 network, but class A is little bit, 2 raised to the power 7. So you will have 126 networks possible in it. And for host addressing, now we are having 24 bits. So out of those 24 bits, again, I am going to deduct 2 combination. So I will just be left with 221. Okay. And if you calculate that number, it will be coming out to be 16777,216 or 214. So see, this much number, 16777,214 number of computers can be connected in a single class A network. So depending on your requirement, how many hosts are there in your network, whether it is 200 or 250 or 1000 or maybe 16,000 or maybe 20,000. Okay. So depending on that, you are going to select the network. So class A is used for big networks. We are having huge number of computers in that network. Go for class A. So moderate number, right? So you are having moderate number of computers. Okay. So that is maximum till 65,535 host per network. Go for class B. But your requirement is very less now. These are small networks, small office, home office type of network. You are just having maximum 254 computer. Go for class C. Okay. So network address, IP address with all bits as 0 in the host portion are going to identify the network address, and IP address with all the bits 1 in the host portion is going to identify the broadcast address. So tomorrow we will see this one because there are certain calculations. Okay, so we are going to see this part tomorrow. So tomorrow we are going to have lots of calculation. I will just give you some IP addresses, CIDR ranges, and I will ask you to calculate the network address, broadcast address, first network address, second network address, and so forth. Okay, so lots of calculation we are going to do in our tomorrow's session. Any question for today's session except this slide, because I'm not going to cover this slide today. So apart from that, do you have any question, whatever we have covered today?
No, ma'am.
Okay. Yes, I will share you this set, all these things, Gaurav. Okay. So I will share you the PDF file. Don't worry. So those who already are having the networking background, so according to me, for those participants, it is very easy to relate to this concept. But my question is for those participants, for them, networking is totally new topic. Okay, so you are not having any prior knowledge. So what is your situation? Are you getting this? Are you finding it difficult? Please let me know. Because our VPC concept, see, VPC is not at all that much difficult. We are going this in little bit detail here, but when you are going to switch to our AWS networking, you will find that it is very easy. But this has to be very much clear, the CIDR range. Okay, so that's why I'm going to do all the calculation in our tomorrow's session. Okay, not today. So tomorrow in fresh mood, we are going to start with all these calculations. You are having any question? Please let me know. Especially those who are not having any background of networking. Otherwise, I'm done for today. So there is no lab or KC, I guess, right? So today we have not done anything revolving on the canvas. But tomorrow, see, tomorrow most of these KCs and labs, because we have covered everything. We have covered all these concepts, internet protocol, means OSI reference model, IP, public private IP addresses, static dynamic IP addresses, right? So tomorrow what we will do, initially we will cover everything with till 262 lab, and then I will take you to AWS networking. Okay, you will find it very easy. Okay, then see you tomorrow if you are not having any question. Thank you.
Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am.